So finding the surface area and volume of some shapes. We're going to start off by looking at the surface area, and then we're going to have a break, and then we're going to look at chapter 20, which is on finding volume of shapes. And then we'll see how that goes, and then we'll think about finding surface area and volume of some compound shapes, and think about that with regard to the assignment you're going to be asked to do. So that's the plan for today. If you look at the textbook, you can see some formulae, common formulae for finding the surface area of some shapes. They are formulae, recipe. How do I find the area of something like a parallelogram? Base times height, but the height here is what's called the perpendicular height. So if I want to find the perpendicular height of some sort of shape like that, I might well have a situation where I've got that side, and I've got this side, and I want to find the height. So what is it that I'm going to need to help me to do that? Yeah, not SOHCAHTOA in this case, because I don't know an angle. Pythagoras, yeah. Remember, tell me what Pythagoras is? A squared plus b squared equals c squared. That's right, Pythagoras. So if I know c squared and I know a squared, I can find b squared. B squared is c squared minus a squared. So Pythagoras is another formula that might well come up too. So in these sorts of problems, okay, here are the formulae, but we also need some other knowledge. We might need other formulae, other mathematical bits of information to help us, and Pythagoras is one of them. Finding the trapezium, the area of a trapezium, the area is a half a plus b times the height. Another way of writing it is, and notice again the height is the perpendicular height, so we might well need to use Pythagoras. Interestingly, if you compare that, what's the formula for a rectangular? It's on the sheet, but you can remember the formula for a rectangular. What is it? What would be the area, the formula for this? If this was A and this was B, what would the area be? AB, multiply A by B. Some of you might want to think about this. Where does the half A plus B come from? Okay. Think statistics. There's the formula for the trapezium. Half A plus B times the height. We know this one, pi r squared for the area of a circle. Note that if you've got the diameter, you don't need to convert that to radius. You could use this formula, pi d squared over 4. And you might want to think about it, why it's divided by 4. Okay. Area of a semicircle, it's a half of pi r squared. Obvious. Area of the sector of a circle, if you think about any fraction of a circle, it's divided into 360 bits. So let's say I want the area of a particular angle. Well, then it's that fraction, theta over 360. So if it was 1 degree, then it would be 1/360th of the whole circle. So 1 over 360 would give me. If it was 180 degrees, i.e. half a circle, it would be 180 over 360, which is a half. So that sort of makes sense as well. So these hopefully make sense to you, these formulas. And I'm pointing this out because you don't necessarily need to remember them. It's quite obvious where they come from if you think about it. This one's not so obvious, so we don't tend to use this one very much, the area of ellipse. But there are some questions on it, and you might well come across elliptical shapes. That's how you'd find the area of it. And the perimeter, the distance around the side. So what I want to do now is to give you some time to have a go at some questions, and then we'll get together and look at some of the problems that have come up from trying these questions out. So if you look at the exercise